Hello, today we're going to solve quadratic equations by completing the square. So how can we use this method? So in this lesson or in this method, we are going to create to produce a perfect square trinomial. So what is a perfect square trinomial? So this is a trinomial, of course, which is a perfect square. So how can we know that? An example of this is x squared plus 4x plus 4. So how come this is a perfect square trinomial? So this is a trinomial where the first term and the last terms are both perfect square. When we say perfect square, it means that they have square root. Let's say if we're going to get the square root of x squared, that is x, and the square root of 4 is 2. And to get 4x, so how come this is 4x? So it became 4x because the second term of a perfect square trinomial is twice or 2 times the square root of the first term times the square root of the third term. So 2 times x is 2x. 2x times 2, that is 4x. And that is why this is a perfect square trinomial. Like for example, if we have x squared plus 8x, how can we make it a perfect square trinomial? In the first place, as you can see, this is a binomial, so we have to add another term to make it a trinomial. And how can we make sure that that will be a perfect square trinomial? So we will be using the formula b divided by 2 squared. If we're going to take a look in this example again, so we have here ax squared plus bx. So therefore b is 8. Substitute to the formula. So we're going to have 8 divided by 2 and the square of that. Following Pember's rule, let's have first the terms inside the parentheses. 8 divided by 2 is 4, and then get the square. So that's equal to 16. So therefore, x squared plus 8x is plus 16 is a perfect square trinomial. So let us have now a quadratic equation that should be solved using completing the square. Like for example, we have x squared plus 6x plus 8 equals 0. So as you can see, this equation is a trinomial, but the third term is not a perfect square. So what should we do? So we have to move 8 on the other side of the equal sign, and this will become x squared plus 6x equals. So since this will be moved on the other side of the equal sign, it will become opposite of this sign. So from positive 8, it will become negative 8. If you'll notice, I left here a blank. Why? Because I will be putting here a term that will make this perfect square. And remember, we have to apply equality here. It means that whatever we're going to add on this side of the equal sign will be the same number or term that should be added on the right side of the equal sign. And what will be that number? Again, we will be using this formula, b divided by 2 squared. And what is the value of b? So b here is 6. So substitute to the formula, we're going to have 6 divided by 2 and the square of that. And that is 6 divided by 2 is 3. Get the square, 9. Positive 9. Therefore, the number that we have to put here is positive 9. The same here. Alright, now we have a perfect square trinomial. So what will be the next step? We have to make this trinomial or perfect square trinomial a square of a binomial. So I have prepared here 2 parentheses and square, which is raised to 2. So I will be putting here binomial. Okay, so what should be that binomial? So the first term here should be the square root of the first term of the trinomial. The square root of x squared is x. And then the second term will be the square root of the third term. And the square root of 9 is 3. and then I'll take the sign of the middle term, which is positive. So this will be x plus 3. The square of x plus 3 equals negative 8 plus 9, 1. So how can I solve for x if this binomial is enclosed in a parenthesis and raised to 2? So we have first to eliminate 2. And if you remember, when we are in extracting the square root to eliminate exponent 2, we take the square root, right, of the given term. So therefore, since x plus 3 is raised to 2, we have to get its square root. And since this is an equality, the same thing that we have to do on the number on the opposite side of the equal sign, or on the other side of the equal sign, get the square root of 1 as well. Then cancel the radical sign and the exponent. So we have here now x plus 3 equals the square root of 1, which is positive and negative 1. Now to solve for x, substitute 3 on the other side of the equal sign. We're going to have here x equals positive negative 1 minus 3. So therefore the values of x are, so let's take positive 1 first. So we're going to have 1 minus 3. And on the other side, we're going to have x equals, let's take the negative 1. So we're going to have negative 1 minus 3. Solve for x. So x now is 1 minus 3, which is negative 2. And the other value of x is negative 1 minus 3. That is negative 4. Therefore, the values of x are negative 2 and negative 4. And of course, we're going to have checking. Let us check if our answers are correct. We're going to check if negative 2 and negative 4 are the solutions to the equation. So again, we will be taking the original equation, which is this one. So we have x squared plus 6x plus 8 equals 0. Substitute negative 2 to x. So we're going to have negative 2 squared plus 6 times negative 2 plus 8 equals 0. So the square of negative 2 is 4. 6 times negative 2, that is negative 12. Copy plus 8. Is that equal to 0? 4 minus 12, it's negative 8 plus 8. Is it equal to 0? Yes. Therefore, x equals negative 2 is correct. What about x equals negative 4? So again, we copy the original given. X squared plus 6x plus 8 equals 0. Substitute negative 4 to x. So this will become negative 4 squared plus 6 times negative 4 plus 8. Is it equal to 0? So the square of negative 4 is 16. 6 times negative 4, that's negative 24 plus 8. Is it equal to 0? 16 minus 24, that is negative 8 plus 8. Is it equal to 0? Yes. Therefore, x equals negative 4 is correct.